Hi, this is Jeff Spencer, Statistics Instructor for the Community College of Denver, and this is a video going over on classwork number 9, problem number 6. So this is our first expected value problem. The point of this problem is to compute the expected value and to compute the expected value and then understand and interpret what that means. So this is the first one that we will do, and the reason why I'm making this video is this is the first one that we're going to do where we have a word problem, a real life situation, and we're going to have to set up the probability distribution. So in our previous two problems with the blackjack situation, the probability distribution was set up for us. You might not know, like when you played blackjack, what the possible outcomes are and the probabilities, which were kind of complicated. So we gave you this distribution. The only thing you had to do was find the missing probability. Same thing on this last one. This was our first basic example. The probability distribution was already given to you. But here we're going to have to create it. All right, so I've already inserted a table in here. Now I'm going to read the problem. It says a life insurance company sells a $250,000 one-term life insurance policy to a 20-year-old male for $350. According to the National Vital Statistics Report, the probability that the male survives the year is 0.998734. So life insurance works this way. People buy life insurance so that if they were to pass away, that in this case, the $250,000, whatever the policy is for, gets paid out to their family so that the family can pay for funeral expenses and other expenses that would be expected to be brought in by the person who passed away. Usually parents do this once they have a family, start to have a family. In case they pass away, the family will receive money to take care of the things that would have been expected to be brought in by the person that passed away through their job or whatever. So this situation is a 20-year-old male. This is just a weird 1-year life insurance policy where the life insurance company sells the policy for $350. Okay, so there's really two situations that could happen just based on the words. So the male could survive the year, or he could not survive the year. Now here are the outcomes. The outcomes are the random variable. This is the profit or loss for the company. Because the problem says create a probability distribution for this situation from the perspective of the insurance company. Okay, and X is the profit. So if the 20-year-old male buys the policy for $350, the company, and then survives the year, the company will make $350. And if the person survives the year, then they just keep the $350. If the person survives the year, there's no payout of the life insurance policy. They just keep the money. We also know that the probability that 20-year-old male will survive the year is, so this is probability of that outcome, is 0.998734. However, there's a very small chance that the 20-year-old male will not survive the year. So in this case, here's what happens. At the beginning of the year, the insurance company gets the $350 from the male. But then the male passes away, so the insurance company has to pay the family $250,000. So they got $350 at the beginning of the year from the 20-year-old male, but then the male passed away, so they paid out, so they are losing $250,000 to the family. So $350 minus $250,000 is a loss of negative $249,650. The probability that this will happen, well, there's only two outcomes. So I'm just going to do 1 minus 0.998734 because the probabilities need to add to 1, and this is going to be 0.001266. Double check that on my calculator. 0.99. I'm sorry. 99. Yeah. Okay. So here are the two outcomes. So I'm going to erase my work here just to show what they are. You don't have to erase your work. I just want to show it a little bit more clearly when I do expected value. So either the two situations are the company can make $350 with a very high likelihood, or they can lose $249,650 with a very low likelihood. This is usually how insurance is set up. So if I do the expected value, I take each outcome and I multiply it by its probability. And then I do this other outcome, negative 249,650, times its probability, 0.000. Oops, I think I added a 0 in there. Sorry about that. Okay, 0.1266. Just FYI, before I had too many zeros in there, there's two zeros. 001266. Okay, when I do this math, let me pause the video here. Okay, my result is, remember this is a dollar amount because that's what the outcomes are here, $33.50. So what this means, remember just like we talked about with the blackjack problem, any expected value is the long-term outcome of the long-term average outcome of this experiment. Remember, the experiment or risk that the insurance company is taking is they'll take $350 from this person and with a high likelihood of keeping those $350, but they do have the risk of paying out $250,000, which is a loss of $249,650 with a very low probability. So they're gonna, if they were to do this and sell this policy to many 20-year-old males, many of them they would gain $350 on, and then a few of them they would lose $249,650. So if the company were to sell many of these policies, they were to do it a large number of times, the average profit, because this is a positive number, would be $33.50 per policy. So that seems like a good, I'm not sure if that's good or not, but at least they'll be making money on the policy. I'll let you do part D and part E on your own, but that's how you set up this problem and interpret the expected value.